For 400 years, we believed we had measured the universe. James Webb just proved us wrong. Out beyond the moon, a massive 1.5-ton telescope stares into deepest time, its gold mirrors silently listening. What it sent back shattered physics. Galaxies too old, too massive, inside a universe that shouldn't exist. Since Galileo first raised a lens, every telescope has refined one answer. How vast is the cosmos? Hubble gave us 13.8 billion years and a universe 93 billion light-years across. But those numbers rested on one assumption, that our measuring tools were finally accurate enough. So NASA built Webb, a 1.5 million kilometer outpost designed to verify everything we thought we knew. 5 tennis court-sized sun shields unfold behind it, cooling the optics to minus 230 degrees. Only that cold allows the instrument to see what light itself has forgotten across billions of years. And when Webb opened its eye, the first image it sent back stopped scientists in their chairs. Thousands of galaxies, bent and warped by gravity, stretching backward through time toward the dawn of everything. Every spike of light in the frame is a star, every smudge older than our sun. Webb sees in infrared the ghost light of a universe still expanding, still cooling, still running away from us. And buried inside its first measurements, a quiet problem emerged. One physicists had feared for a decade. The universe, it turned out, was expanding faster than Hubble had ever recorded. The numbers didn't match. This gap between old and new measurements now has a name. Scientists call it the Hubble Tension. One method gives 67 kilometers per second. Another gives 73. Both cannot be right at once. A 5 sigma disagreement, which in physics means the probability of coincidence is less than 1 in 3 million. If Webb is correct, the standard model of cosmology, Lambda CDM, is beginning to visibly fracture. Somewhere in that gap, either dark energy behaves differently, or our entire understanding of distance is broken. If the expansion rate is wrong, every number we wrote about the universe must now be rewritten. But the expansion rate was only the first crack. What Webb found next nearly broke physics entirely.
Welcome to the frontier of discovery. What Webb found next wasn't just anomalous, it was impossible.
Webb turned its gaze further back than any instrument before, into the first few 100 million years. At that age, the cosmos should be chaos, hot gas collapsing, tiny clumps, no real galaxies yet. For decades, every model predicted a universe still brewing its ingredients, not yet ready to cook structure. But on Webb's first deep scans, fully formed galaxies began appearing. Bright, structured, massive, enormous. Astronomers assumed a mistake. They recalibrated instruments, rechecked data, and ran the numbers again. Nothing changed. Each recalculation returned the same impossible answer. These galaxies were too old, too mature, too soon. A new phrase entered the literature that year. Scientists began calling them, quietly, universe breakers. Jade's GS Z14-0. The most distant galaxy ever confirmed. Its light traveled 13.4 billion years. Its stars had already formed. Its structure was stable. Yet Webb sees it as the universe just began. Sears 93316 followed. A monster galaxy so massive it alone breaks the rules of cosmic evolution entirely. Then GN-Z11. Too bright, too early, glowing with the luminosity of something that took billions more years. Each was confirmed by spectroscopy, the gold standard. No calibration errors, no statistical anomalies, no escape route. Within months, dozens more were catalogued. An entire population of galaxies that the early universe couldn't build. Supercomputer simulations of early galaxy formation began failing. The output no longer matched what Webb kept observing. Cosmologists faced a stark choice. Either our timeline of the universe was wrong, or physics itself was. And inside that second possibility lay something terrifying. A deeper break hidden beneath everything we believed.
Novatech, where the universe stops making sense. We decode it.
What scientists found next forced them to rewrite the rules of how galaxies are even born. Traditional models said galaxies need hundreds of millions of years to organize. Webb's data now said otherwise. If early galaxies formed faster, something in the primordial universe must have seeded them with terrible efficiency. Some theories now suggest dark matter played a far more aggressive role than anyone previously dared imagine. Others propose the universe itself may be older than 13.8 billion years, perhaps far older. Either way, one conclusion becomes unavoidable. The universe we thought we knew may not exist at all.
We return to the frontier with two unavoidable truths. The universe is larger and older than imagined.
The standard cosmological model, Lambda CDM, governed every prediction we made about the universe for 30 years. It rests on dark matter, dark energy expansion, and a precise timeline of 13.8 billion years. Every number checked against every observation, until Webb's measurements refused to fit inside the framework anymore. The Hubble Tension stretched the model. The impossible galaxies broke its back. A third crack now emerged. Dark energy, once assumed constant, appears to be weakening over cosmic time, shifting its grip on expansion. 3 separate surveys in 2024 returned the same anomaly. Cosmic expansion is not behaving as expected. Taken together, the Lambda CDM framework is no longer intact, held together by mathematical tape and prayer. Theorists around the world now race to draft a replacement, a model that survives Webb's revelations. Modified gravity, evolving dark energy, extra dimensions, each idea carries its own weight of fresh impossibility. And beneath every theory sits the same astonishing structure. Webb is finally allowing us to see clearly. The Cosmic Web Filament. Vast threads of dark matter stretching across billions of light years, connecting everything. Galaxies are not scattered randomly. They hang along these filaments like dew beads on a spider's thread. Where filaments cross, enormous clusters form. The great cities of the universe, glowing with billions of stars. Between the filaments lie the voids, vast empty regions, some 100 million light-years wide. Zoom out far enough, and the universe looks less like scattered galaxies and more like a biological neuron. This structure resembles the human brain at microscopic scale, a pattern repeating from smallest to largest. And yet this entire observable structure may be a fragment, a single bubble inside something far vaster. Beyond our cosmic horizon, regions of the universe exist that light itself will never reach us from. Some cosmologists now suspect the true universe is not 93 billion light-years, but functionally infinite. We built the map. We measured the distances. We gave the universe its age and its boundaries. But Webb delivered a verdict we were unprepared to hear. The map we drew was simply wrong. The true scale of the universe is something we are only now beginning to realize, for the first time, seeing.
If this opened your eyes to what's next, hit that like button. Subscribe to Novatech and stay at the frontier of discovery. There's more to uncover. Click the video on your screen now and continue the journey with us.